Hi, welcome to the chemistry edition of Darling Fee's channel. My name is X-Coco and I'm excited to bring to you more concepts. In this lesson, we will look at the calculations only. Please don't forget to do this. Kindly subscribe to this channel to see more of our videos. We will look at amount of substance, which is mole with a small symbol small n. We also consider relative molecular mass and molar mass. Take note of this. Relative molecular mass is having a symbol Mr, which has no unit. Molar mass has a symbol capital M, and the unit is grams per mole. Now let's look at some basic terms. When we talk about mole, this is the amount of substance which contains the same number of carbon atoms in 12 grams of carbon-12. Molar mass is the mass of 1 mole of any substance. Please take note of this. The molar mass of any substance contains Avogadro's number, which is 6.02 times 10 to the power 23 particles. Now let's look at the formulas here. For you to be able to calculate amount of substance, which is small n, calculate mass or molar mass, we need to know these formulas. So we have small n to be equal to m over big M. That is the amount of substance, which is the mole, is equal to mass over molar mass. Mass is in grams. Molar mass has the unit grams per mole. Please take note of this. Now we have big N to be equal to small n times L. Big N here denotes the number of particles or the number of entities, which refers to atoms, ions, and molecules. L here is Avogadro's constant, which is 6.02 times 10 to the power 23, and it has a symbol Na or L. Now let's look at the combination here. In this formula, we have small n. Over here too, we have small n to be equal to mass over molar mass. So in place of this small n, we can insert mass over molar mass. So when you do that, you will get this common formula, which is big N is equal to mass over molar mass times L. I hope you get it. Please don't forget to keep this formula. Okay, now let's look at relative molecular mass and molar mass calculation. Please take note of this. You'll be given what we call atomic masses. So we have nitrogen to be equal to 14, hydrogen 1, oxygen 16, aluminium 27. S here is equal to 32. So that is what we use in calculating relative molecular mass and molar mass. Now let's look at the first one, which is on relative molecular mass. Please take note of this. From one element to the other, we use plus. So from here to this element plus, from this element to the next element, we also use plus. Please take note of this. Check whether there is a number attached to any of the elements so that you can multiply. So in the first one, we have nitrogen plus 4 here times H. So 4H here plus Cl. So that is what we have. After doing this, what you have to do is you go back to your atomic masses and insert them. We have 1 times nitrogen because there's no number attached to this. It is only 1. Plus 4 times hydrogen. That is the atomic mass of hydrogen. Plus 1 times 35.5. So after summing them up, you will get 53.5 without the unit. So now let's look at the molar mass calculation here. We have Al bracket NO subscript 3 bracket close subscript 3 here. So with the same approach, we have to expand this. So that will give us Al plus 3 here is multiplying n. So 3 times n plus 3 times 3 here will multiply oxygen. So we have Al plus 3N plus 9 times oxygen. So what do? We just have to revisit the atomic masses given and insert them in the expanded form here. So we have Al, which is 27 times 1. We have 3 times N, which is 3 times 14. 9 times oxygen, which is 9 times 16. So when you put everything together, you will get 213 grams per mole. Please don't forget to bring the unit. It is very, very important. Let's look at more. First one is on relative molecular mass. So what do? We just have to expand the whole thing here. So we have 2 times Na plus S plus 4 times oxygen. The dot here in expanding, we use plus for the dot. So take note of that. Then we continue. 10 here is multiplying hydrogen and it is also multiplying oxygen. So that will be 10 out, 2 times H plus oxygen. So what is the next step? You just have to insert your atomic masses. But let me take you through this again. So we have 2 times Na plus S plus 4 times oxygen plus 10 to bracket 2 times H plus O. So you insert the atomic masses given and that will give you 322 without the unit. Now let's look at the second one, which is on molar mass. We have NH4 subtract 2 SO4. With the same approach, we are going to multiply 2 times N plus 2 times 4 plus S here plus 4 times oxygen. So after doing this, we insert the atomic masses and at the end, we are getting 132 grams per mole. Okay, so before we start with the calculation, let us look at some basic principles here. Now, whenever there is a question on atoms, please do consider the number attached to the element. So in the case of sodium, we have 3 atoms of sodium here. Phosphorus, 1. Then oxygen will give us 4 atoms of oxygen. So let's assume that there's a question indicating that you are to calculate the number of sodium atoms. That will be 3 times the formula. What if you are being asked to calculate the number of ions for a particular ion? How do we go about it? Please go by the same principle. That is, you consider the number attached to that particular element. So in the case of chlorine, we have 2 moles. That is 2 ions of chlorine. Over here, calcium will give us 1. So that will give you 1 times the formula. All right, now let's start with the calculation. How many atoms are there in 0.3 moles of sodium? So this is the first question. Now let's go through the question together. We have 0.3 moles. The 0.3 with the unit indicates that we have been given N, which is small n. Big L here is given, which is the Avogadro's constant. So automatically, you knowing the formula, big N is equal to small n times L will give us 0.3 times 6.02 times 10 raised to the power 23. And the final answer will be 1.806 times 10 raised to the power 23 atoms. Now let's move to the second one. We are going through this together. The question says, calculate the number of hydrogen atoms in 0.5 mole of methane gas. We have been given the mole of methane, which is 0.5. The question says we are to determine the number of hydrogen atoms. How many hydrogen atoms do we see in this compound? It is 4.
So we have to look at that number here. Now let's start. As I told you, if it is number of atoms, do consider the number attached to that element. So the formula becomes big N is equal to 4 times N times L. Now when you multiply, you will get 1.204 times 10 raised to the power 24 atoms. We attach atoms because the question asked us to calculate the number of atoms, not molecules. All right, now let's go through the third one. The question says that how many molecules of oxygen are present in 3 grams of the gas? So we have O to be 16, L, Avogadro's constant is given. Now let's look at the question. The question says how many molecules, which means we need big N. What were we given? We have 3 grams here. We also have our Avogadro's constant. In here, the question said oxygen gas, so that will be O2. So we have to calculate the molar mass of this. Please take note, anytime you see mass or you hear of mass, molar mass should be present. Meaning that when you are not given the molar mass, you have to do your own calculation to determine the molar mass. So from O2, we had 32 grams per mole. So big N is equal to mass over molar mass times L. That is a combined formula because we had mass given to us, molar mass is determined from here, and we have the constant, which is L. So inserting that in the formula will give you 5.64 times 10 to the power 22 molecules. We attach molecules because the question said we should calculate the number of molecules of oxygen. Okay, so now let's look at the last one. The question says, calculate the number of chlorine ions in 0.2 grams of aluminum chloride, AlCl3. Al has been given, Cl2 35.5. Then we also have L given to us. So what do? We knowing the mass given here, and we knowing the molar mass, which is being calculated from aluminum chloride, which is 1335 grams per mole. We insert that in the formula. But take note of this. The question said chlorine ion. So we have 3 here, which is multiplying chlorine, which indicates that we have 3 moles of the chlorine ion. So that will be 3 times the mass over molar mass times L. So when you insert that in the formula, you will get 27.05 times 10 raised to the power 20 ions. Thanks for watching.